Hello again, folks. Today we're going to be covering section 6.7. Pardon me, not 6.7, what am I saying? 6.4. According to our schedule. And today is Tuesday, after all the very big storm. It's actually flurrying right now, but we are scheduled to cover section 6.4, so we'll be doing that. The packet that you should attempt to print, put this aside, is mostly the examples. I swiped this from the textbook. This is a nice diagram of the three types of variation equations. There is in fact a fourth category. I'm going to draw that for you in a couple of minutes, but we'll go through these examples now. There's quite a few of them. Right. So do try to print that, and we'll go over it together, as close to together as we possibly could be under the circumstances. All right, now let's see. Let me give you an overview first. Okay. What we're going to be discussing are referred to as, let me turn the light on and see if that makes a difference. It's a little bit better, perhaps. I try not to cast a shadow if I can help it, but unfortunately I have a window here. There are four types of what are referred to as variation equations. And basically, if it's an equation, what does that mean? Well, there's going to be an equal sign and a left side of that and a right side of that. And the left side is a first variable, so a letter. And the right side is one or more other variables. And usually what is going on this side, the right side, is either multiplication or division or some combination. Anyhow, think of these as basically being a model you can borrow. And modify, right, to whatever the unique problem is that you're dealing with. Right, and there'll be four types basically. The three that I have sort of alluded to here, these three. And then there's the combination, which was, for all intents and purposes, let's count it as a fourth category. Okay. So here are the examples you'll have. There is firstly direct variation equation. And then there's inverse joint. And then there's the combined model. Okay. So let me show you how you would write it. I'm going to purposely put it in different colors just to sort of emphasize what the variables are and what the extra parts are. Since all of these are going to be an equation from which you will choose, they're all going to naturally have an equal sign. So I'll make sure that that is in the frame. Good. All right. Get my little cup out of the way here. Okay. And I'm just going to use variables x, y, and things that are around that in the alphabet. Oftentimes equations are y equals because we're talking about two variables and they graph them on a coordinate plane. So if you've ever had high school algebra, very likely you've seen a horizontal and a vertical coordinate axis. So they use x's and y's. So I'm going to just make this a blue y. In each of these cases, it doesn't really have to be, and in the unique problem, it won't likely be at all. But just to start with, again, this is a model from which you will choose and then modify to your liking. And if we're talking about two variables, one related to another, I'll put an X here. In each of these cases, in different places, beware of this one, it's low. And you see the similarities here. And then, in some cases, extra. The most basic type is the direct variation, all right? And it relates one variable to really just one other, but by virtue of a constant, right? All right. This k that you see here, it's a script k, is called a constant, a proportionality constant. And all that that really means is that it is the obvious number. The other things may be in your problem remain a letter, but that is the one thing that should be the obvious number. Right? It makes this multiplication true in this instance, and this division true in this instance. Right? Direct variation is one variable is related to another variable by virtue of multiplication. Inverse variation is that this variable is related to this variable by way of division instead. Right? And it's just these two variables and that constant. This actual number will be here. Right? If you have joint variation, it may be two variables. So we'll have a constant, some number thrown in there, but there will be an extra letter, and since we've used x and y, why don't we just go with the third variable, z. Okay. Then the combination would be a little bit of multiplication, a little bit of division. These are just multiplying two variables, and this would be multiplication and division. So you'll have the proportionality constant, you'll have that extra variable z, and then some kind of division by a another letter. I'm out of different colors, so I'm just going to go back to blue here. We'll call this W. Take a sip of water here. Okay. Now I'm going to give you an example of each one of these, but let me do one thing first. All right. There's the algebraic, mathy sort of way that you would look at this and read this. Y equals k times x. Right? That's pretty straightforward, right? And then there's the verbal way that you would refer to it. I think that that is important, especially since English is frequently confusing, because it has conflicting sets of rules. So for these two in particular, I'm going to sort of spell it out grammatically, all right, how you would read it. as sort of a visual aid when you're reading your word problems. Kind of look for certain suspect phrases as you would with operations. I'm a little short on space, so what I'm going to do is I'm going to erase this. It's still direct variation, and I'm going to add this just above it here. You might read this or apply this as a model when you see this sort of phrasing in English. Y varies directly as X. The most operative term there is directly. If you don't see any other key features, written verbally here, just go with this model, right? Maybe change the letters to whatever they're talking about. So if they're talking about an area, maybe use an A instead. If they're talking about time, use a T instead. Y varies directly as X. It's kind of awkward, right? The way that is presented, but you'll see that, right? An option is that they will just simply say Y is directly proportional to X. These are really the same statement, just phrased two different ways. I'm going to erase this now. Okay. In the case of inverse variation, if you're going with this as a model to borrow and modify, the phrasing would be something like this. They'll say, Y is inversely proportional to. Or alternatively, Y varies inversely as X. Right? When X is basically being divided, or we could say it looks something like a denominator, all right, then you're using this model. Right? If you see some kind of combination of phrases, all right, it would be probably the combination variation model. If you see something that is just, it only says directly, but it may refer to two variables simultaneously, all right, go with the joint, all right? If no division is involved at all, you're gonna go for this one if you see more than one letter. All right. Pardon me, this is just multiplication. So if you're talking about two extra variables on the right side here, and it's just multiplication, doesn't say inversely at all, go with the joint. This and this. All right. Now, as some examples, it's getting a little bit messier and messier. For direct variation, an example would be a formula that you already have some relationship on that, undoubtedly. Right? Distance formula. Distance equals speed multiplied by time. Now this is a little bit more verbal than it is symbolic. Right? I'm using whole words to represent variables, distance, speed, and time. Right? But if I just reduced it to d for distance, s for speed, and t for time, lowercase t, you can see that there's a similarity here. All right? It's just two things being multiplied together, right? And then one variable on the left side of the equals, right? If you were to take the distance formula and rearrange it specifically to solve for either speed or time, right? In which case you would perform opposite operations to move stuff around. Let me say that I solved for speed. I want to get speed alone. I'll divide by t here and divide by t here. Then I have an inverse relationship. It's the same exact formula, it's just rearranged. Rearranged S is equal to D over T. In this instance, you would have an inverse variation relationship. Same exact formula again, it's just rearranged algebraically to look like that. A joint variation problem would be something like simple interest. We had discussed that a while ago. Last week, I shouldn't say, it's not that long ago. Simple interest is I is equal to P times R times T. So what if they're capital letters? It doesn't matter, right? It's three things being multiplied, just like K times X times Z is three things being multiplied. That would be an example of a joint variation. Something like combined variation, the closest example that I can think of, and you're not inclined to see this in this class, is the ideal gas law. So if you've ever taken chemistry, you might have heard of the ideal gas law. Right. And all it is, again, three things being multiplied and one variable being divided. And that would look like this. PV equals nRT, that's how I remember it. P is for pressure, V is for volume, N is for number of moles of substance, that's basically how much matter you're dealing with. R is the actual constant, that's the K value basically, and T is temperature. If you rearranged this ever so slightly so that there was just one letter, hopefully this is in the frame, one letter on the left side and all the other interesting parts on the right side, you would maybe divide by V, volume, and put that down here. Right. Something divided by itself, even if it's mysterious, cancels. And you have pressure is equal to, I'm going to purposely put this in a different arrangement. I'm going to take what I know from experience personally as the constant and put it up in the front. And never mind that these are capital and lowercase letters mixed together. Just look at the position of these variables, these letters, compared to the model. This would technically be the constant in the ideal gas law. It's known as the gas constant. You don't really have to worry about this. I'm feeling around for an example that most closely resembles this. X is, again, the number of moles, which is the amount of substance, right? T is temperature. So two things being multiplied that are variable. Mass is variable, or pardon me, number of particles is variable, and temperature is variable. And then divided by a third variable. So in this case, it's volume as opposed to W, whatever that is. Okay? Three things multiplied and then divided. The real important, the essence, all right, of algebra is this comfort that you develop. I should say, the essence of what you should be doing is developing a comfort of manipulating equations, moving stuff around at will. And I just want to remind you before I move on to the examples, right, to solve algebraically, in case you hadn't seen that video, the gist is to perform opposite operations. And then in order to make it legal, due to both sides. Of the equal sign, right? It doesn't matter if it's a number that you're doing opposite operations, performing that on, or if it's a variable, or if it's a word, right? As long as you know that you can use the operation at hand, right? And you basically decide this way. If you see addition, in order to move something over equals, you subtract. Right? Those are opposite operations. Instead, if you see multiplication, which is sometimes just a dot or not even, the two things are just pressed together, to justify moving over equals, you divide, right? And vice versa. Right? What makes anything legal in math world is that you do it to both sides of the equals, right? You can get away with murder in math as long as you're consistent. Be consistent, right? That makes everything legal. Okay. Drawing on myself again. All right, let's do some examples, and you'll start to see, I think, what I mean. So as I said, if you would, maybe print this out, and I'm going to try to project it so I don't have to write it. Let's turn on the camera first and see if that works. I put up a curtain, so hopefully I can sort of make this more visibly pleasant. Ooh, that is really blue. The all-seeing eye here. The computer's asleep. There you go. All right, as I tell you frequently, let me get rid of this. If you need to print anything, as long as you can navigate to the through Canvas to our particular course, right, then what will be available to you all of the time, at least by the day of the recording, are the relevant handouts, the packet material. So if you were, say, in MAT-113 INA 24, you could go directly to Pages and click on, there's more stuff here than what you normally see. Just things that have little green check marks. Right? If you go to Pages directly, you could see these are lists of the material. Right? The packet that I made for you today is this black 6.4 variation equation examples PDF file, right? Which I'm not inclined to want to just simply view here, because it might be a little bit blurry. Right? But anyhow, that is where you could get it from. Right. I'm going to just borrow the copy that I have on my desktop here, because I think it might be a little less blurry. Let's see, you notice, right? All right. Anyhow, this is the same thing. Okay. Now, I don't know if I'm going to get myself in trouble here. I don't have a lot of space to write with the projection in the way, but let's see what I can finagle. All right. The length that a spring will stretch is going to be called S, right? And it varies directly with the force or weight, which will be called F, unique to this problem, attached to the spring. Write an equation for the length that the spring will stretch, all right, if the constant of proportionality is 0.07, all right? What I would do is, what I have been trying to convince you to do is circle what you consider relevant information, right? Even if that changes. This is an actual number, and referring to it as the constant of proportionality. So if this is direct variation right off the bat, this is the model that you want to borrow. And in place of the K, you're going to put that number, 0.07, right? The other two things, Y and the X letter, will be replaced by the initials that are unique to the problem. So if we're talking about a spring length, all right, that is varies directly, then you might put S in place of Y, right? Because they're referring to the situation with this as being a reference, so that is first, all right? And then the F is attached to the spring, that is the F that would be attached to 0.07, all right? So you would say Y is equal to K times X, and in place of the Y, you're putting S, and in place of the K, you're putting 0.07. It's the actual number, the obvious number. And in place of X, you're putting F. And you might say, how come the F didn't go here, and how come the S didn't go here? They're not playing any tricks on you in a problem like this. They're basically trying to get your feet wet. So if they say S varies directly with force, that is, stretch varies directly with force, then this is the thing that is mentioned first, so it's going to go in place of Y, all right? And this is the thing that is mentioned second, so it's going to be on this side, okay? And there's nothing else to it. They're not giving you any other conditions. I think this is a little too dark, so I'm going to assume, moving forward, that you have this printed, all right? And I'm going to walk you through these examples. I'm going to read them to you, all right? Normally, if we were in a full-size classroom, I would project this on one board and write on another, but I don't have but one board here, okay? So, get rid of that. And I'll write what I think what you should look for, okay? For the subsequent problems. Okay, now if you look at number 2 here on the packet, it says direct variation in medicine, all right? It'll always start out being a little verbose, right? Don't be intimidated. Just realize that you have artistic license to dumb it down a little bit, right? Get the essential information. Look for certain words, and then maybe write them yourself, right? This is another thing. I mean, don't ever be apologetic about writing something. This is how you learn, all right? And if you're in the position of teacher, don't ever tell a kid not to write something, all right, when they're doing their work, legit work, right? Don't let them do things in their head exclusively is what I'm getting at, all right? I hate that, you know, especially when they're young. How else do you show a person your thoughts but by writing, you know? All right, enough speeches here. All right, here's example 2. That's in the frame, good. It says the recommended dosage D of the antibiotic drug vancomycin, whatever that is directly proportional to a person's weight, which will be designated W. And they want you to do 2 things. All right. Here is this. Write the variation equation, and then determine using specific numbers. All right. All right. What I would do is this. Look for the word the phrase directly proportional. Look for the phrase inversely proportional. This will decide, right, which of these you're going to start with. have 4 models, and it's really 3 to start with. Directly, inverse, joint, combined. That's a little bit out of the frame. So like that. All right. So in this, they say specifically that it's directly proportional to. And rephrased slightly, you would say the letter that they're talking about is D, right? Never mind what it represents, is directly proportional to weight, W. Okay. If you, and there's nothing else added to this, if you see this directly proportional or varies directly as, then you're going with this of the 4 models that you have to work with. Y equals K constant X, right? What you're going to do is now substitute the letters that are relevant to the problem. I think I alluded to this maybe last week. All right. When you see the word is, this is a visual cue that you have an equals right here, which is great because anything that is before it is the left side of your equation, and whatever is after it is the right side of your equation. So in place of Y, you're going to put D because it's D is. All right. In place of the actual variable, the thing that can vary or changes, we're going to put W here in place of X because the constant is supposed to be K. All right, the actual obvious number in the problem should be sitting here. Okay, now this was basically part A, right? But now they're going to give you some conditions, right, for part B, all right? Having modified this, I'll write it here a little bit nicer. D equals the constant, whatever it may be, times the weight. Dosage equals the constant times the weight. All right. It says, determine the recommended dosage in milligrams. You don't have to worry about the units too much in this class, in a physics class, and in a chemistry class, and in a biology class. Certainly you would. But anyhow, you can always just verify. The constants, a lot of times, it's not just a number, it's a number with a slew of units that cause cancellation of the existing units. So that's why I say you don't really have to worry about it, right? That's for a physics class. Determine the recommended dosage for Jace, who weighs 128 pounds. Assume the proportionality constant for the dosage is 18. They don't tell you any of the units, right? So, in place of the constant, or what you know is standing in place of the constant, you're going to put 18, all right? Right. And we'll figure out what the dosage would be if the person's weight is 128 pounds, right? You would multiply these two things together, 18 times 128, and this would equal 2304. Milligrams is usually abbreviated mg, right? Like on a vitamin. And if I'm being very good boy here, I'd put a comma. At least in the United States. All right. And that's it. You know. Again, don't worry about the units too much. The units in an upper level math class or a science course would be helpful only because they would validate what your suspicions are. If you know how to basically incorporate the units together, right, they may cancel or they may amplify, like they would square, like inches times inches is inches squared when they multiplied. And then you would know that you are dealing with an area, say, or whatever other subject. But if they don't give you any variables attached to this constant, then you can't cancel anything, all right? So you ended with milligrams probably because this constant has milligrams in it, all right? Anyhow, it's two things multiplied, and that is your answer. Okay. All right, let's do the next one. Example 3 on this packet. Again, I'm going to read it to you just because it's a little bit easier than turning off the projector several times. Suppose W varies directly as the square of Y. All right. Here's an example. This is 3, technically. It says suppose that, all right? But I'm going to take a little artistic license, set a good example for you, and rephrase it, right? Let's just say W varies directly as the square of Y. Okay. In the sentence it says suppose here. Suppose that, but baloney, you're going to end up using this, right? So Y varies directly as the square of Y, right? Right at this point, the only two things that you've been taught to look for are things that either vary inversely or directly. So you see varies directly here, right? Of these two models to borrow, this one or this one, it most closely resembles the first again, right? Stupid thing is out of the frame. Let me see if I can move this ever so slightly. So this is better. I'm either cutting off the bottom or the top. I think that might be better, so I'll leave it like that. All right. That'll have to suffice. Right? Of these three basic models, directly, inverse, and joint, all right, they use the word directly, so it most closely resembles this one, at least to start with. So I'm going to start with writing out the model. Y equals K times X, right? Unique to this problem is another phrase thrown into it. As the square of Y, rather than simply say as Y, which is what this model would say, right? Right, as X. It's just backwards. Notice another unfortunate thing. They've used the letter Y, right, at the end of the sentence here, and they've used W. So we really are going to have to substitute those letters, right? This says Y varies directly as. That's the first thing. So that's going here in place of W, unique to this problem. And then, for whatever reason, they decided to use Y, all right, for the tail end of this, all right? This is last, right? So that's going here, ironically, perhaps, in place of X, right? No sweat, right? The other thing is that they say square. Square is when you have an exponent of 2. Right? So if it's a square of Y, that means that there's a 2 here. Right? And that is enough of a modification, really. If I wrote it a little bit cleaner, a little bit nicer, a little bit neater, it would be W is equal to the proportionality constant times Y squared. All right. And going a little bit further, let me read 3. If they'll give you some conditions, right? I'm going to be reading basically this portion of it here, and then do the problem. Right? Here are the conditions that they're specifying. And again, I'm oversimplifying it because it helps, right? If W equals 60, all right, when Y is 20, find the proportionality constant is K, right? To say proportionality constant is K, so you're going to be looking for this, right? All right. We're going to insert these figures appropriately in the model we've just modified, and then rearrange it algebraically to solve for K, because you notice that the K it's got a buddy here, it's got Y squared, so it's not solved for that. Right now, this equation is solved for W specifically because W is all alone, right? As it is, this is solved for W. But we need it to be solved for K to find K. So let's insert those figures. There'll be a 60 here, and there'll be a 20 here. We do have to follow the order of operations. We do have to do a little bit of rearranging, perhaps. But I'm going to move this now. And I'll write it up here because it's a little bit needed now. We have this now. 60 is equal to K, script K, times 20 squared. What's 20 squared? Remember, if you're trying to simplify before you move over the equals, use order of operations. If just simplifying one side. All right. When you move over equals, use opposite operations. All right. Right now I'm just trying to simplify it. 20 squared is really 20 times 20, right? So what's 20 times 20? 400, right? 2 times 2 is 4. 2 zeros is 400. Okay. Now, if we are again going to solve for K, that means I have to now move this over here. Could you have gotten away with moving the 20 squared first? Yeah. All right. But just be careful. All right. If I want to now solve for K, K equals something, I have to do the opposite of squaring. The opposite of multiplication, which is what that dot is. What is the opposite of multiplying by 400? Dividing by 400. And the tendency in algebra especially is to use this bar when we mean division, okay? And again, legally speaking, you can get away with murder as long as you're consistent. If you divide by 400 here, divide by 400 here. Something divided by itself is 1, which you don't have to write. That is kind of the whole point. You're trying to simplify. So K is equal to the outcome of what 60 divided by 4 is, 400. There's a couple of, you could use your calculator at this point, and you could write it here on the left side, or you could write it here on the right side. My preference personally, because I'm just being anal retentive, is to write it like this, but it means the exact same thing. And this is again a script K, it's supposed to be. It just has a lot of flair here as an antenna to communicate with the mothership, you know, anyhow. So here's some tricks, right? If you're doing this by hand, 0 here and a 0 here, cross them out. It has the same relationship as if you're dividing 6 by 40, right? These are both even. You could divide both of them by 2. That's the GCF. Half of 6 is 3. Half of 40 is 20. And then if you're converting a fraction to a decimal, which is going to be important in the next section, you would divide the top by the bottom. Pardon me, the bottom, yes, it is the top, divided by the bottom, like so. How many 20s can you squeeze into 3? You can't, it's 0. How many 20s can you squeeze into 30? 1. And the difference between 20 and 30 would be 10, right? So that would be 100 instead. This is short division. 20 goes into 100 exactly 5 times, right? So K is equal to this, 0.15. Again, you could verify this with your calculator. Okay. Let's do number 4. Again, do not be afraid to take a little artistic license and rephrase the overly verbose word problem. All right? They are sometimes designed to throw you. So dissect them at will. Right? Takes a little bit of confidence, and it does take a lot of experience, but eventually you get there. All right? You have a plan. All right? Let me start with this now. Okay. Number 4 from this packet. All right, it says the area A, lowercase a, of a picture projected onto a movie screen varies directly as the square of the distance d from the projector to the screen. That is overly verbose. Right? Verbose is probably enough of a phrase. I'm being redundant. It's verbose. It's wordy. All right? Take it and just spell it out in one sentence. All right? That means the same thing. Dumb it down. All right? So my instinct is this. All right? A varies directly. All right. As the square of distance d, I'm just going to call it d. Yes, A stands for area and D stands for distance, but this is the essence of what is being said here. This variable varies directly as the square of d, right? Without even reading the rest of the sentence, which is me setting a bad example, really. You should read the whole thing, but you can already mold this into something useful. You can't resist the temptation, so I'm going to do that. If it says varies directly, then we're going to start with this model that we know that we have. Right? If this is mentioned first, then it's intuitively going to be, in place of this, is going to be A. And if this is mentioned last, then this is going to be intuitively positioned here. In place of Y, we use A for area. In place of X, we use D for distance. And then there's going to be a constant here as well. They do throw in, again, this phrase, square of. If it's the square of D, that just means there's going to be a 2 here. All right? Now to continue. If a projector at a distance of 25 feet projects a picture with an area of 100 square feet, some of this is spelled out verbally, like they'll put square feet, they'll actually type out square, S-Q-U-A-R-E, versus putting a 2 to abbreviate. All right, what is the area of the projected picture when the projector is at a distance of 40 feet? Again, dumb it down, take what is essentially there. Look for the word is, all right? So here's what you could glean from this. Distance of 25 feet. Distance is equal to 25 feet. And I'm using the abbreviation FT, right? That is in the frame. Looks like it's okay. All right, that's the first point. With an area A of 100 square feet. Square feet is abbreviated as feet times feet, so feet with a little exponent of 2. All right. What is area? You could just put A equals question mark, right? When D is a distance of 40 feet. So to simplify that, say when D is 40. And you could use the unit. Okay. We can plug in the first set of the first pair of conditions. We could certainly put this into the model that we have modified. The only thing is that there's 3 parts here, and again, we're not going to have a proportionality constant. So even though they didn't specify explicitly, hey, you should figure out what the proportionality constant is, you can infer that. All right. So I'm going to put in 25 and 100. So in place of A, I'm going to put 100. Right? In place of 25, D squared, I'm going to put 25. And I'm putting a little parentheses here just out of habit. Right? Sometimes in upper level math, you have a negative and you have to be careful. Right? Squaring would affect the negative too. So you have this really. You have 100 is equal to the constant that we don't know times 25 squared. You can simplify one side before you start doing algebra, or you could rearrange the model first algebraically. I'm going to just intuitively do the simplifying first. So I'm going to put that over here because I'm short on space. What is 25 times 25? 625. In the year 2525. It's a song. All right, a lame song. I shouldn't insult it. I didn't write it. All right. We have now really 100 is equal to K times 625. I'm gonna get sued. All right. Now, if I bring this over here to figure out what K is, I'm going to divide by opposite operation. Opposite of 25, multiplying is dividing. And if you did it here, do it to the opposite side. This is going to tell me what K is. Think of this in terms, if you're going to do this by hand, think of this in terms of money. If that's $1 and this is 625, think of quarters. How many quarters are in $1? 4. How many quarters are in $6.25? 1 for sure. And then 6 times 4, which is 24, right? 24 plus 1 is 25. Yuck. All right, so let's see. I'm confusing myself. Let me do it brute force to verify. Makes me feel better. 25 goes in, I'm using a GCF, that's why. 2, yes, which is 50 to 1. 25 goes in, yeah, I was right. Okay, so good. 4 over 25. K is equal to 4 over 25, which again, that's a fraction. We would ideally like this to be a decimal. We didn't get to section 10.1 yet, but it's about conversions like this. You could use your calculator to do this. 4.000. 25 goes into 4. No, it doesn't. It's too small. But 4 goes into 40 roughly 1 time, which is 25. The difference of 25 and 40 is 15. So it's 150. All right. 25 goes into 156 times, right? Yeah. So K is equal to 0.16. All right. Again, we need to figure out the K value, we just did, according to the original pair of circumstances here. And then we can actually answer the question, because now we have we need the 2 pieces of information that we would need. I'm going to erase a little bit because I need the space. So we know that K, well, we have this. A is equal to K times D squared. I'm going to stuff in the thing I just calculated. So this would be A is equal to 0.16 times D squared. And now I'm going to figure out what A is by inserting a 40. So if I put a 40 in place of d here, I would square it first according to the order of operations. I'm just sticking with one side. I should just do that. Just do the direct operations, exponents before regular multiplication. And this would end up being 1600 times 0.16, coincidentally, it's similar digits here. Okay? So we end up with, you should get area equals 256 feet, all right, squared. Now you might wonder naturally, well, geez, buddy, where did you get these units of feet here? In the problem, they specified that the distance was 40 feet. So in theory, if you put feet in here along with the number 40, it would be affected by the exponent of 2 and become 1600. 4 times 4 is 16 with 2 zeros. And the unit would also be squared. So this is abbreviated as feet squared, which is perfectly sensible because we're talking about an area. And areas are squared, always. Whatever the unit, okay? So this is what you should get, 256. I don't want to belabor the point, but just to prove to you that if you did include the units to begin with, back when we were looking for K, you'd see that there's a cancellation effect. I think that's worthy of our time, so humor me for a minute. We had done this before, we, the royal we. A is equal to K times D squared, right? And essentially, I had inserted the numbers here and here, right? But I could have just manipulated the model without the numbers, in which case I would perform algebra right off the bat. Divide by D squared here, divide by D squared here. Remember, right, you can get away with murder in math world as long as you're consistent. I know that this is squared, but who cares? If you want to justify moving something from where it is over equals, you perform algebra, which is the opposite operation. So if it says times d squared, divide by that. And then here and here. This is unknown to us, but it's something divided by itself. So by sheer logic alone, something divided by itself, unless it's 0, that's the only exception, would cancel to 1 every time. Well, 99.9% of the time, unless it's 0. So you have K is equal to A area over D squared. If I put the units in now, right, the area was what? The area was 100 feet squared to begin with. And down here, the distance was 25. Let's see. Feet. I'm going to put a little parentheses to group these things, right? Again, that is an anal retentive habit that I have because I know from dealing with upper level math, if there's a negative here, or if there's a unit, that would be affected by the exponent of 2 simultaneously, right? In other words, you're going to square the number and also the unit, right? So the effect is that 25 times 25 is 625, and the effect of feet squared is feet times feet, is feet with a 2. So you would end up with the same exact figures. Now look what happens, all right? 100 over 625 would reduce to this as a fraction in simplest form. You could enter this into your calculator right now and you get the same answer, right? Here's proof, all right? 100 divided by 625. It's a little blurry. 0.16, right? Insofar as the unit is concerned, this is two like things. A unit that is a factor of feet squared over a factor of feet squared. I know they're not numbers, but it doesn't matter. When you have factors, like factors, one above the other like this, even if they're diagonal, they cancel. And that leaves you with something that has no unit. Right? And now, this should be your answer when you all said and done, 256 feet squared, because it's an area. All right, moving on. Okay, I'm very breathy right now. I need some water. let's do number 4. Pardon me, number 5. Okay. Number 5 from this packet. Again, it's rather intimidating perhaps because of the paragraph, but don't be intimidated. You're going to take it and you're going to chop it down, whittle it down to the essential information. All right. It says the loudness, L, lowercase l, of a stereo speaker measured in decibels, right? Decibels is a unit of loudness, right? Varies inversely as the square of the distance d of the listener from the speaker. Take that information and just draw out the essential information. We're telling you about 2 units, L and D, and it is specifically, it is L varies inversely as the square of D. Nothing else is important right now. You don't even care what they represent, just using L and D. If you see this phrase varies inversely, then you know that you're going to go with this model. Y equals K, a constant, divided by X model. All right, and we're just going to adapt it, modify it to the unique letters here and here. So it is intuitive. L is mentioned first, so I'm going to put an L here for loudness. And D is mentioned last, so I'm going to put D here in place of X. All right. They did also include, as in the last couple of problems, square of. So that means it's D with a little 2 here. A little bit nicer, a little bit neater. You can see this. L is equal to a constant divided by D squared. Loudness varies inversely as the square of distance. All right, again, decibels is just a unit for loudness. If you went to the airport, I want to say like the air traffic that is landing is like, or airplane engines at least, is like 100 on the scale. So really, really loud is 100. That's why those guys have those muffs on. Those people, right? They look like they're talking to somebody, right? No. All right. If the loudness is 20 decibels dB, right, when the listener is 6 feet from the speaker, all right, determine the equation that expresses the relationship between loudness and distance. We really do have the equation already, but we don't have K, so it's not really complete, all right? So what we're going to do is we're going to take the information that is described in this second sentence and then fill in the voids and, if necessary, rearrange the parts. So, all right, it says if loudness, so if L is equals 20 and dB is decibels abbreviated, that's just the unit, right? When the listener is 6 feet, they don't say the word distance explicitly. They say this person is 6 feet away from something. So that is when D essentially is 6 feet. FT is a unit for feet. All right. Determine the equation that expresses the relationship between loudness and distance from the speaker, right, using these figures. Now, a general equation. I'm going to take the model that we have modified slightly, and I'm going to rearrange it algebraically first so that we figure out what K is. You could put the numbers in as we had done in the last couple of problems first. All right, there's no sin in that. But it might be a little bit easier in the long run to just stick with the letters and move the stuff around at will. If you want to solve for K, you got to get that alone. How do you do that? Algebraically. Which which means you're going to perform opposite operations. Okay, sorry for the using red and put it next to it. What is the opposite of dividing by d squared? And I know that I have to move d squared over equals somehow because we want to get k alone. The opposite of dividing is multiplying, and it's just sufficient to put a dot for multiplication above the line technically. If I did that here, there's a cancellation effect. I'm obligated, my hands are tied now, to do that here in a similar way. All right? That means that k would be equal to whatever d squared times L would be. And now I could manipulate, I could substitute these figures here, 20 and 6. So I'm going to put 6 in place of d, and it's going to be squared first. It would be squared first even if this was behind it, because it's exponents, and exponents take precedent over regular ordinary multiplication. They're more important, right, unless something is grouped somehow. And 20 is going in place of L. So, square, multiply. All right. 6 squared is really 36 times 20. 36 times 20 is really 72. With an extra 0 is 720. You could throw the unit in there if you want to, but it really is superfluous. You don't really need to do that. All right? That means that if I take this number, 720, which is what k is, and then go back to the model that we have modified, it would sit right there. Which means that our model is now L is equal to 720 over d squared. We took the general model and we've adapted it. Now we have to just substitute a number here and a number here if we want to do some other problem. Right. But they're not asking us to, so that's sufficient. All right, here's 6. Using the constant of proportionality. All right. Again, if you look at number 6, it says, suppose y varies inversely as x. All right? Never mind this suppose business. They're setting you up. All right? So, to rephrase that, all right, you would say, yeah, y varies inversely as x. All right? That means right off the bat, all right, I'm skipping steps a little bit, but hey, I'm going to have to do this ultimately anyhow. If y varies inversely, and they don't mention anything else, right, then you know that it's going to borrow from this model. Right? Okay. And then they specify some conditions. They say, suppose y varies inversely as x if y equals 9, then they're being pretty plain spoken here, when x equals 12, determine or find, same difference, find y when x equals 4. All right, these are just numbers, no units either. All right. This is another situation that if you took the pair of substituted substitutable, that's not really a word. If you took this pair of numbers to substitute here and here, you could figure out k, but you have to rearrange it to solve for k. So you could either do that, you could do the substitution immediately and then rearrange algebraically, or you could manipulate the model first and then, substitute. I'm going to go with that train of thought. All right. Again, if you're going to solve for k, you got to get k alone. How do you do that? Opposite operations. This is algebra. All right. What is the opposite of dividing by x? Multiplying by x. To put a dot here and have it slightly up higher, as if it was on its own little platform, all right, is sufficient. If you did that here for the sake of cancellation, you are obligated to do it there. All right. Which means that k is equal to y times x, or vice versa. It doesn't matter in the case of multiplication, which is written in front. All right. There's the commutative property of multiplication. It technically would look like this because of the way I left it. All right, now substitute in 9 and 12. All right. So in place of y, what am I going to put? If y is 9 and x is 12, 12 times 9 is 108. I can now go back to the model, the modified model. Y equals k over x, and put the value of k, the constant, the proportionality constant. So in place of k, I'm going to insert 108. And then I could figure out what y is, because it's already arranged to solve for y, when x equals 4. 108 divided by 4. All right, 4 goes into 10 roughly twice, which is 8. The difference is 2. 4 goes into 28, 27. So y should be 27, whatever the unit is. Let's do number 7 here. Okay. They tell you, as an example, here's number 7. It's going to involve joint variation. But even if it didn't specify in the instruction or the heading of the instructions, you could still figure it out by suspect phrases, and that's a good habit to train yourself to look for things. So this number 7, it says the area A of a triangle varies jointly as its base B and height H. All right. Forget about what it's talking about specifically. Stare at the letters and then look for the words jointly, or inversely or directly. All right. So dumbed down, it would be this. You'd say A, and they're using a capital in this case, varies jointly as B and H. So rather than just as one letter, it's 2 letters. Right off the bat, you can translate this because you see this phrase, jointly, into the model y equals k times x times z model. Right. And we'll just substitute the things that are unique to the problem. So A is mentioned first before the word varies. So it is intuitively standing here on this side of equals. Jointly as B and H, we'll just go in succession here in alphabetical order. K is a constant. We got to leave that one alone. B goes here. H maybe goes there. Now we're talking about the area of a triangle, so it makes sense that a B and an H would be used because base and height are part of the area of a triangle formula. You don't really have to worry about this, but it's nice to have this in mind. You've probably seen the area of a triangle formula. That's what it would be. A half times the base times the height. A little bit cleaner would be this. K, H, and B. Right? Now, it goes further to say, if the area of a triangle is 48 inches squared, if A, that's area, is 48 inches squared, that's a unit, when B is 12 inches and H is 8 inches. Determine the area of a triangle. I'll change colors for this. Determine, I'm going to dumb that down and say find, it means the same thing. All right. Find A when B equals 15 inches and H equals 20 inches. Remember, the word is easily substituted by the mathematical symbol equal sign. Right? This is another example of where you have to look for the proportionality constant yourself because they won't tell you. So you could rearrange this to solve the K first, or stick in these unique numbers here, 48, 12, and 8 now, 3 variables. All right, here, here, and here, and then rearrange it. Right? I think it might be easier without the numbers and the units in the way. So I'm going to manipulate first, right? If we want to solve for this, I'm going to freeze it in place there. And I'm going to move the junk that is adjacent to the opposite side, both of them. They're both being multiplied, right? You could do them simultaneously too. It might be more concise if you do that. If you want to justify moving anything from the right side over to the left side, perform opposite operations. What is the opposite of multiplying? Dividing. But I'm not just dividing by one letter, I'm dividing by 2 letters. If I did it here, my hands are tied, I'm obligated for the sake of balancing. This is the beautiful Zen aspect of algebra. Do the same thing here and here. Right? You can put dots if it makes you feel more comfortable. I don't know what B is yet. It doesn't matter. We're generalizing. It's something divided by itself. This cancels. Right? It's something divided by itself. This cancels. That's the whole point. Right? That means that this could be rewritten in respect of K. And I'm using regular K. I should have used script K, but it doesn't matter. Is equal to A over B times H. Right? Now I'm going to substitute 48, 12, and 8. And I'll just use the numbers right now because the units would cancel. In place of A, I'm going to put 48. In place of B, I'm going to put 12. And in place of H, I'm going to put 8. You can, even in this form, with the dot here and the line here, simplify at will if you feel comfortable. If you don't feel comfortable, combine these things and then just, make a calculated divide. Right? In the long run, eventually what any person does is they look for shortcuts that are legal. All right? And you might recognize relationships here. So I'm going to go ahead and do that just to set a good example. I recognize that there's a relationship between 48 and 12 from the multiplication tables of 12. Makes me more strategic if I have some information memorized. All right? So I could do this. I can simplify. 12 divided by itself to simplify is 1. 48 divided by 12 is 4. All right? The leftover guts here, 4 and this 8, coincidentally can be simplified. You don't have to do this, but it would be strategically cool. All right. 48 and 8 have a relationship. All right. So they're simplifiable. All right. 48 divided by 4 is 1. 8 divided by 4 is 2. That means that the whole thing is really a half, which is really 0.5. Right? 1 divided by 2 is 0.5. Right? If you didn't do it that way, it's 48 divided by 96, right? Because that's what 12 times 8 is. Right? And 48 is exactly half of 96. You'd get the same answer one way or another. Right? I'm only mentioning it because I want you to realize that when it comes to math, you frequently have options that you don't take advantage of, and you should. All right? So just be aware. Save it in the back of your head, even if you don't use it. Oh boy, why am I losing that breath? I think my collar is choking me, so I'm gonna loosen this, and maybe now I can breathe a little bit better. All right. My diaphragm. I'm having to hunch all the time because of the nature of the camera and my board here. If I die, this video will never be uploaded, so you won't see me dead and you can't help me. All right. Anyhow, not to be morbid. If you throw the units in, I just want to prove to you that everything works out and it comes down to the wash, right? Inches squared would be up here. 12 inches would be down here, and 8 inches would be down here. What is the abbreviation for inches times inches? It's inches squared. What is inches squared divided by itself? Even though it's not a number, even though it's an abbreviation for a word, even though it has an exponent of 2, they're the same thing divided by itself. All right, one thing divided by itself is still going to cancel, so you're just left purely with the numbers involved, nothing else. Yeah, I feel like I could talk better now without being choked. I'm going to strangle your math teacher. Please, you may feel that way, but please don't do that. All right, so we figured out what K is. I'm going to go back to the model here. I'm just going to rewrite it because it's a little bit too much mess here. And then we'll answer the question. We got a half, 0.5. A more elegant version of this would be A, the area, is 1/2, or 0.5 if you like, times B times H. If you put 0.5, that's cool. If you put a half, that's cool. Sometimes it's more convenient to have a fraction, and sometimes it's more convenient to have a decimal. All right, depends on the figures that you're working with. Now, in the specific problem here, it says find A if B is 15 and H is 20. So if I put a 15 in here, and I put a 20 in here, all right, you can, again, use your calculator. There's no sin in that, all right? And then figure out what it is, right? 15 times 2, this is 1 times 15 is 15. 15 times 2 is 30. With an extra 0 is 300. 2 times 1 is just 2. It's asking you what's half of 300. The area would be 150 in terms of the numerals involved. All right. If you're concerned about the unit, I would deal with it as an afterthought. It's inches for 15 inches. It's height of inches, so it's inches. Inches times inches abbreviated is inches squared, which makes total sense because we're talking about an area, and areas are always two-dimensional. Right? That's a 2, I swear. It's just got a lot of flair. Right? It's like an alpha's 2, if you will. Right? There we go. Moving on. Developing a nice hump in my middle age here. All right. That was number 7, right? Yeah. All right, let's do the most complicated type, which is not to be intimidating. The combined type. Number 8, down here, I purposely gave it a tried to give it an obvious heading here. We're reading this one here. All right. The load, capital L, that a horizontal beam can safely support varies jointly as the width W and the square of the depth D, and inversely as the length lowercase l. All right. Again, take it. Don't be afraid. Dumb it down to the bare essential. Right? You don't even care right off the bat what they really represent. Just use the letters when you're writing a smaller sentence, a shorter sentence, I should say. All right. So we got a capital L. Varies jointly as W and the square of D and using an, so this is supposed to be a sort of an abbreviation for and. Inversely as the length as L, lowercase l, right? Capital L for load, lowercase l for length, right? D for depth, W for width, I believe, right? Yes, okay. This is essentially all of the information, just, it's essential, right? Never mind the extras that they threw in there and the commas and whatever have you, all right? Even if they didn't tell you up front, hey, this is a combination problem, combined variation, you could take this immediately and, having seen the word jointly here and the word inversely here, realize that you're using this model. Okay, y equals the constant times these two variables divided by this variable. Right? Just substitute now the letters unique to the problem. In place of this is first, right? So you're going to put an L here. The constant, you don't know what it is, right? Unless they specify. W is what they're using in place of X, so it's going above the line in this instance, unique to the problem. Square of D. So we would put a D here, but we're going to also put a 2, all right, because they say square of D, all right? And inversely implies this line, division really, all right, of lowercase l. So you would have an L down here, all right? This is me superimposing my scribble on what I wrote originally in red. And this is the same thing, a little bit more cleanly written, a little bit more obvious, I hope. The load varies jointly between the width and the depth squared, and inversely over the length. I almost put my mark in my water. I have two different mugs, and unfortunately they're both black. Taste the red. All right. Now, let's see. To continue with this, it says, express L in terms of W, D, and L, and the constant of proportionality K. For this particular problem, we're done. Right? This is really what they just wanted us to establish. Right? So we did that intuitively. All right. The hardest part of teaching math is to get people to not be afraid, right? Understandably, right? They're afraid oftentimes because they've been battered, emotionally beaten up, all right, by people who are not so caring. So when you're in the position of math teacher, be very gentle with people, right? And realize that in the long run, anybody can figure anything out, all right? They just need a little encouragement and a little direction. And somebody with patience. If you're not a person who's patient, don't teach, all right? Stay home. Go someplace else. Do something else.
and realize that that is your shortcoming, that you're not patient. All right. All right. Now, number 9. Read this. All right. The owners of Henrietta Hots determine their weekly sales of hot dogs, S, vary directly with their advertising budget, A, and inversely with their hot dog price, P. All right. When their advertising budget is $600 and the price of a hot dog is $1.50, they sell 5,600 hot dogs a week. All right. Again, get in the habit of taking the verbose word problem and dumbing it down to the essential. Never mind what they represent, use the letters involved that they've chosen. They say essentially this: S, weirdly, varies directly with A, and inversely with P. All right, that is the first sentence whittled down to the essential. Okay? If it's directly, then you know it's going to involve multiplication. If it is inversely, then you know it's going to involve division. So, taking this and recognizing that it's a combination of those two things simultaneously, we're going to start with the model and maybe just, modify it. X and Z over W. There's a lot of flair for that. Too much. Let's substitute a little bit here. This is mentioned first. So in place of Y here in the model, I'm going to substitute an S. Okay. It varies directly with A, so the first letter here is A. All right. K is a constant always. All right. And inversely with P. So inversely with P would be down here. Now in this instance, we don't need the extra letter. All right. So what we have is this. We have S is equal to K times A over P. Isn't that great that you can, at will, throw away the parts that you don't need? All right. Now they do specify Henrietta's Hots. All right. It says that with their advertising budget, which is A, of $600. That's a little faint, right? Can you see that? I think green fails me frequently. Let's see, try this different green marker. And the price, P, of $1.50, they sell this many hot dogs, 5,600 dogs. All right. So we have how many variables? Technically 1, 2, 3, 4. And we have 1, 2, 3 substitutions here. So, what's the one that's missing? Once again, it's the proportionality constant. So, if we're going to answer any other question, you might intuitively go, well, I probably should figure out what K is, even if they don't specify that. Right? They do tell you in the instructions, write a variation equation using these. include the value of the constant of proportionality. That is their way of saying, hey, figure out what the actual number is that's here. And the only way that you can is by substituting these specifications first. Okay? So for the sake of space, I'm going to erase this. Okay, so I'm going to put this in green up here because it's easier to write over that. S equals K A over P. And now I will put 600. You can put the unit dollar if you want. All right. They go in front. Again, not to be an anal retentive jerk here, but dollars are not a measurement. So you put the dollar sign in front. You don't put it at the end here. Measurements, you put at the back. Dollars are counted. They didn't involve a tool that you measured with. All right. P is $1.50. All right. And S is so many hot dogs sold. So 5,600 would go here. All right. And you could rearrange it first to solve for K. In which case, I'll jump the gun a little bit and I'll show you what it would look like. All right. The P would move via multiplication. And the A would move via division in 2 steps, like that. So you'd end up with this. Right? You could manipulate it without the substitutions, all right? Or you could plug in the numbers and then simplify them. All right, maybe we'll do that first. In this instance, you have a unit of $1 on top and a unit of $1 below. That would justify cancellation of them, and you're just left with purely a number. All right. Now, there's lots of tricks here for decimal division here. You could, if you want to, just divide 600 by 1.5, right, and figure out what it is. And then you're going to end up it's going to be one factor here, which means it's multiplied, right, rather than in 2 parts. And then you're going to divide it to bring it over here. Here's a trick if you want to do this by hand. All right, you see 2 decimal places here, bring it over, and now it's there. If you make that alteration to the bottom, be consistent to do the same thing to the top, which means that the relationship of 600 to 1.5 is the same as apparently 60,000 to 150, which is awful, granted. But then you could pull this trick. Decimal there and there now. A pair of zeros. Pairs go away. There's a relationship between these two, right? Which you recognize maybe from time, right? An hour is 60 minutes, and then a quarter of an hour is 15 minutes. That means they're both divisible by 15. 15 divided by itself is 1. All right, 60 divided by 15 is 4. That means that there's 4 with these extra 2 zeros here, right? When all is said and done, what that means is that you have 5,600 is equal to K times 400, right, left over. This reduced with this, right? You would still have to solve for K in this instance, all right? And you would do so by opposite operations. When you move over equals, you perform algebra, right? When you stick on one side or the other exclusively, you perform arithmetic, right? Divide by 400 here, cancels. Divide by 400 here. Why cancel? Because it's something divided by itself. It's 1. You don't have to write 1 if you don't want to. In most instances, it would be preferred not because it's less complicated looking. All right? 56 divided by 4. Pair of zeros. Pair of zeros. That's like dividing by 100 without consciously thinking about it. It's a GCF, really. There's a legitimate reason, but it is also a shortcut. 56 divided by 4. 4 goes into 1 roughly one time with 1 left over. 4 goes into 16 exactly, 14. That means that K is 14. All right? If you didn't do it that way, by inserting directly and then manipulating, start with the figures that you see here, and I'll do it now. And rearrange this to solve the K. All right, how so? Do it in 2 steps. All right, we did it in a single step last problem, but this one would kind of require 2. If you're going to move the P from here to there, the opposite of dividing by P is to multiply by P. I'm just going to put it a little bit higher up, and it's enough to put a dot there. This is this times this, it cancels. I would be obligated to put it here. All right. Simultaneously, this is multiplying by A. If I want to justify moving A from here to here, it's the opposite of multiplying, which would be to put it down here, divide by A. If I divide by A here, I'm obligated to divide by A here for the sake of balance. All right, these would cancel. Yes, we don't know what the numbers are yet in this instance, but by sheer logic alone, it's something divided by itself, so that would intuitively be 1 when it simplifies, right? And you have PS over A is what K is left over on one side, on the right side, okay? So now, what does that mean? It means that if we took our equation that we adapted to the problem, number of hot dogs sold, Henrietta's Hots, is equal to K times A over P to start with, and then incorporated this 14, it would be S is equal to 14, that's a funny way to write it for, times A over P. And now you can answer anything more specific. You have a generalization that's good to go. All right, so the rest of the problem is this. Determine the expected sales if the advertising budget is $800 and the hot dog price is $1.75. Right? If this model holds true, you can use it to make predictions. Right? Predict sales if these 2 conditions are met. If the advertising budget is up to $800 and the price of the weenies is $1.75. Yeah. $1.75. Okay, so in place of A, I'm going to put 800. And again, you put the unit of dollar in there. It's not technically a unit, it's counted. It's a kind of unit, it's just not measured. And then the price of $1.75 down here. And you can enter this into your calculator. All right, you can pull tricks or just do this. Type 14 times 800 first, divided second, $1.75 at last. Right? That would be correct order of operations. You straighten out the top, and if the bottom were more complicated, you would straighten out the bottom, right? Then divide dead last, right? With your calculator, right? So, here, I'll show you. So, this calculator does have one feature that's kind of cool. It has parentheses, so you could very carefully tell it what to do first. If you incorporate parentheses in your entered information in your calculator, it's specifying that you want the calculator to focus on the things that are in parentheses first all the time. So I would do that when you have something too complicated. So 14 times 800, all right? Say something like that, you see? And then divide by $1.75, all right? So you see it's a / on your calculator screen, equals 6,400 hot dogs, right, is the number that would be sold. Woohoo! They become so abundant, they'd be our currency. It's an old joke. On Saturday Night Live years ago, there was a character called Harry Carey, which is based on a real person. He used to say crazy things like that. He's like, hot dogs. The 20 hot dogs would equal roughly a nickel. I'm not quite sure. It depends on the strength of the yen. Anyhow, 6,400 hot dogs is the way that this calculation would work out. It's quite a lot of hot dogs. All right, last question, number 10 here. Combined variation is the one that is the most involved, I guess, because it's last. All right, it says A varies jointly as B and C, and inversely as the square of D. All right. By this point, hopefully, and if not, don't be discouraged. It comes with time. All right. Just keep doing anything and you get good at it enough times. To say, for number 10, A varies jointly with B and C, and inversely with D as the square of D. You could take this and translate directly into something that is a usable model, something that at least can be modified. Right? Good habit is, again, you look for certain phrases like jointly, directly, or inversely. In this case, when you see jointly with two things, that's appropriate because jointly is more than one variable. Right? You would have y is equal to k for the constant times two variables. Okay. Inversely means that you're going to divide by the other letter. When in the model it's w, right? So we're going to borrow this, right? And now we're going to substitute these capital letters instead. All right. A is first, so it intuitively is written on this side of the equals. Jointly as B and C, and inversely as the square of D. So it's going to be D again, but the square is going to be down here. All right, a little bit nicer and neater is A is equal to K is times B times C over D squared. Okay. All right. Now, having gotten that, let me erase this. For the sake of space and clarity, hopefully. And you see this, right? They give you some specific conditions. I'm going to write them here. If A equals 1, when B equals 9, C equals 4, and D equals 6. Find A when these conditions are met. When B is equal to 8, C is 12, and D is 5. Now, how is this different really from any other problem you've done to this point? It isn't, all right? Notice that the model that we have sort of crafted here has 1, 2, 3, 4, 5 letters. And you have 1, 2, 3, 4. So you have the majority of information. That's kind of the rule of algebra. As long as you have most of the information, you could figure out what the missing information is. All right? I could substitute them here, 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 and here. And then I could figure out the thing that I don't have. What is the one thing that I sadly don't have? And I have the proportionality constant. So if I'm going to answer this question, I really need that too. I can't have two things missing. I need one thing missing at most. So I'm going to take their conditions that they specify, stuff them in this model, rearrange the parts, and then figure out what K is first, just like all the other problems. Okay? Maybe it would be easier right now, again, not to involve the numbers, right? Just stick with the letters and move them around at will. And don't be scared, all right? So we'll do this slowly. I'm gonna solve the K, so I'm gonna freeze that in place and move everything around it, all right? I'm gonna start with D. This is being divided here. If I wanna move D from here to here, to the opposite side to get it away from K, to solve the K, because K's gotta be alone, I'm gonna do the opposite of dividing, which is to multiply by D squared. And if I did it here, I'm obligated to do it here. What is going to happen 100% of the time is that there's going to be a cancellation effect. Right. Simultaneously, and you could write this in more, if you have paper, you could write it in several steps. I'm going to move the B and the C. Right? Since they're both being multiplied, I can take the two of them at once. Right? What is the opposite of multiplying by B and by C if I want to move them from here to here? Dividing by B, dividing by C, and if I did it here, I have to do it here. The effect of dividing something by itself is that it cancels. B's would cancel because there's one above the line and one below the line. C's would cancel because there's one above the line and there's one below the line. It's for a different reason than the D, because it's a different operation involved, but it's still the same logic. Okay, so K is equal to D squared times A over B times C. Right? We can now insert the blue figures in here, and it's already set equal to K, so we don't have to divide anything after the fact. Pardon me, we don't have to perform algebra, it's just arithmetic. Okay, so in place of D, I'm going to put 6. It will be 6 squared. In place of A, I'm going to stick 1. In place of B, I'm going to put 9. And in place of C, I'm going to put 4. This is straighten out the top first. 6 squared times 1, you should square first. It's order of operations because I'm just sticking with one side. I'm not moving things over anymore. I already did that. All right, so this is really 36 times 1, which is just 36 on the top. The bottom, coincidentally, 9 times 4 is 36 as well. So what's 36 divided by 36? In the same way, I mean, if you didn't even know, something divided by itself is 1. In this case, I have to put the 1 because I can't just have a void here. All right? But now I know what that number is. Right? And now I have the majority of information, so I can figure out what A is directly. So I will do that. Here's my model, modified. With that one alteration, which is kind of unnecessary because it's just a 1. But that's where it would be. It would be sitting here where the K is. All right. So I'm going to stick in these conditions now. In place of B, it's 8. In place of C, it's 12. In place of D, it is 5, but it's 5 squared. Right. So if you straighten out just the top, it's 8 times 1 times 12, which is 96. If you square 5, it's 25. Right. So the A value, whatever it represents as a quantity, physical quantity, right, is just whatever 96 divided by 25 is. Right? If you use your calculator, right, just enter 96 divided by 25, it would look like this, / all right, and you get 3.84. Right? 3.84. And that's that. Okay. That's pretty much everything. Okay. So for homework, if you're keeping up with the schedule, and you really need to be because there's a looming deadline. All right. Let me refer to the calendar here very quickly. We are in February, of course.
All right, here's February. We just covered section 6.4. The last section I'm going to cover this week is 10.1. All right, and then technically you would have a test. I'll specify conditions for this at that time. All right, you want to work on the homework assignments that have been covered to this point. The deadline is the evening of the February 9th. I have that posted in Canvas. Okay, I want more than anything. I cannot sort of impress upon you. Your homework is the most important thing, all right? It's the experience, not some test, that matters. You notice when I have your grade designated on the syllabus, the majority of your grade is the homework. I know in ordinary circumstances that would be exactly the opposite. Usually homework is not given so much gravitas, but this is Corona world, right? So anyhow, in a weird sort of twist of events, right? Homework, which is experience, is rightly where it should be. The most important thing, the experience that you get from doing something, all right, however long it takes you, all right, is the most important thing. That's how you learn, by doing something a lot. It doesn't matter what the subject is, okay? This is why patience is important, especially if you go into the field of education. You need to be patient with people, all right, especially children, little kids, all right, and with yourself, all right? So make sure that you're catching up. I know some of you had trouble getting an account together. You have, you know, just under a week now, just about a week to work on those assignments, right? And they take a little time, so, you know, reserve that time, okay? For homework, in theory, do section 6.4 in my lab, all right? Don't let it wait too long, okay? All right. Thank you guys for hanging out. I'm gonna go shovel. All right. Be careful out there.